Exponential rules and scientific notations. So let's first talk about exponential rules. Whenever we're talking about exponential rules, we have some base that's going to be raised to some power. All right. So if our base here are like bases, as you see here in this example, we have A as my base raised to M times A raised to N. So my bases are alike here. If the bases are alike, I can write the base down one time. And that means my powers here, because we are multiplying the like bases, my powers are added together. Well, we don't know what A, M, or N is, so that would be my final answer. But if I come over here and picked one of these that has a value for it, so for example, let's use one that's not on here. Let's say I have 3 squared times 3. Well, we know 3 here is raised to the first, but it's not written, right? Because that's not simplest form. However, the base is 3 and they're both alike. So I can write the base once. And since we're multiplying the bases, that means the powers are going to be added. Well, 2 plus 1 is 3. So this tells me that I'm going to say 3 times 3 times 3, which gives me 27. So you have to give the value simplify it if we know the value. Okay, where A and M and N, we didn't know no more than that because nothing else was given. So this is using the product rule. Now let's talk about the quotient rule. Quotient means division, right? So if we're dividing, and I'm going to use this A for example here. If we're dividing by like bases and they're raised to some power, and we know that if it's no power written there, it's seen as 1, then that means we're going to write that base once, and then we're going to subtract top minus bottom power every time. So I have 6 minus 1. I don't know the value of x, so x is going to stay x, but I do know the value of 6 and 1, and let's subtract them. It gives me 5. And that would be my final answer. Just remember, if you have like bases, you write it down once. And if it's multiplication of the bases, we add the powers. If it's division of bases, like bases, we subtract top power minus bottom power. All right, let's talk about the 0 rule. So any number except for 0 will equal 1. 0 will not equal 1, right? So let me say this again. Any number raised to the 0 power will always equal 1. So I'm going to give you an example. I'm going to use 3 again as my base. I have 3, and let's go ahead and square it. 3 to the first, 3 to the 0, 3 to -1, 3 to -2. This is going to answer some of the other things we're going to get to next. Well, we all know 3 squared is 9. Well, if I divide this column here by the base, in this case, the base is 3, then 9 divides 3 gives me what? 3. Well, that's correct because 3 to the first is 3. Well, let's divide this again by 3, which is my base, right? We're dividing by my base. It gives me 1. So 3 to the 0 power is equal 1. Now let's divide this again by 3. And this is going to give me 1/3, which is 3 raised to -1. We divide it again by 3. We get 1/9, which is 3 raised to -2. Okay. Power rule. So this tells me that if I have some base, right, raised to a power, and I turn around and raise it to another power, then that means I multiply the powers. So let's use an example. Say that I have 2 squared and I'm going to cube it. Well, 2 is being squared, but it's also raised to the 3rd power. So now I know I have 2 times 3. which is 2 to the 6th. Now we know the value of 2, so we're going to have to multiply that out 6 times. 1, 2, 3, 4, 5, 6. So that I know this is 4 times 4 times 4, or you could have said, I have 16 times 4, which is what? 16 times 4 is 64. I'm going to double check myself, and I believe I am correct. Yeah, 64 is correct. And that would be my final answer. All right, power of product rule and power of quotient rule. So let's work on the power of product rule first. So this tells me that I have two bases being multiplied together, and they're both raised to some power, and I'm going to turn around and raise it to another power. We know B and A, those bases are not alike, so we can't put them together by writing that base down once and raise it to the power and add them, right? We can't do that. However, I could say, oh, I have A raised to M, and that means since I'm raising it to another power, I'm multiplying the powers, times B raised to M, and I'm raising it to another power, so I'm multiplying that power. So this would be my final answer because I don't know the value of A, B, M, and N. However, let's say that I have 2 times 3, and 2 is squared, and 3 is to the first, and let's raise it to the cube. Well, 2 and 3 are not like bases. However, I can square 2 and times it to 3 and get that, but I'm trying to make a point here. What if this 3 here is an X and not a 3? So let's do that. Let's change it up a little bit. Let's just make it an X. Well, we don't know the value of X, but we definitely know that X and 2 are not like bases. So I'm going to distribute the power. So I have 2 squared, and I'm raising it to the cube. I have X to the first power, raising it to the cube. So since I have a power raised to a power, that means I'm multiplying the powers. So now I have 2 to the 6th times X to the 3rd, and 2 to the 6th power, we did what ago, gave us what, 64. So that would be our final answer. Okay. Oh, and let's do the quotient rule. So now let's talk about division of the power rule. So if I have bases that are not like being divided, and we raise it to the power, we're still going to multiply the power. So I have A raised to M raised to N. I have B raised to M raised to N. That would be my final answer because I don't know the value of A, B, M, and N. However, if I said, oh, okay, I have 2 over Y, and Y squared, and I'm raising it to the 3rd. Well, I know 2 is to the first on that one, so I'm going to have 2 raised to 1 times 3 because I raised it to the 3rd. That means I have Y squared raised to the 3rd. So now I have 2 cubed over Y to the 6th. I know the value of 2, so let's go ahead and multiply that out, but we don't know the value of Y, so we're going to leave it in this format. Okay. Now let's talk about negative rule. The negative rule, if your power has a negative number, we cannot write that as our final answer because it is not the simplest form. So if your base is raised to a negative power, we're going to write it in its reciprocal, and that's going to cause it to flip, right? It's going to cause it to go to be a positive power. Y'all saw that earlier when I said that I had 3 raised to -1 came out with 1/3. And if I divided it again, it would be the 3 raised to -2, which is 1/9. When we flip it, it gives us our reciprocal. All right. What if it's already in the denominator? Well, we're going to pull it out of the denominator. We're going to flip it, and it's going to make it a positive number. Or excuse me, a positive power. Now let's talk about power versus root rule. There's multiple ways to write this. I'm going to put the nth root because it could be the square root, cube root, fifth root, fourth root, seventh root, whatever it may be. And it's going to have a radicand inside it, which is going to be some base, right? But we call it a radicand, and it's going to be raised to some power. It could be 1, it could be 5, whatever that power is. We can also rewrite that as the nth root of the radicand A raised to the power P. Excuse me. And we can also write it as A, the radicand, raised to the power divided by the root. There we go. So let's use an example. I really like C. C is a good example. So I have the square root of x to the 5th power. I can rewrite x in a format that I can factor down easily and pretty. I notice that this is a square root, right? That means it's 2. We don't write the 2 there. If it's a cube root, you would, right? You would write the cube root. But the square is the smallest root, so we wouldn't do that. But I can break down this x to the 5th using my product rule. If I had like bases being multiplied together, I add my powers. And I know that if I take 1 away from 5, it leaves me with 4. And I know 4 will reduce with 2. So now I can rewrite this as x to the 4th divided by 2. So the power divided by that root times the power divided by that other root in there. So now I got it all broke down. 4 divides 2 gives me 2. So that means this is factored out. I have 2 x's that are factored out. That 1/2 says that it did not factor out, and I left it in there. Okay. So let's do the square root of 8. Well, we all know the square root of 8 gives us 4 times 2. And we all know what's the square root of 4. We all know it's just 2. Doesn't always work out that nice and easy. Sometimes you're going to get a number that you don't always know. So we have to use this rule here that we used on C here. All right, scientific notation. Let's talk about scientific notation. I want to use this written notation here. I got A dot B, C, it could be D, E, F, whatever, it may go on and on. However, if they have a bunch of zeros, they're not going to list the zeros. We don't want to do that. That's the whole point of scientific notation. Scientific notation is used really in science a lot, and mathematics, because you can get numbers that are so monstrous big or so small that it's hard to not make a mistake if you're trying to calculate and type up or write down every digit. So scientific notation is going to be a shorthand notation. So think about it. It's A here is in front of the decimal. So A can only be 1 or 2 ... all the way up to 9. It cannot be 10. It cannot be 0, but it can be 1 through 9 or 9. It could be any of those. And then all the digits behind it will be some number. You don't want to list the zeros. And then it's going to be times 10 raised to some power. If this power has a negative number, then that means it's a really small number, and we're going to move our decimal in this direction when we take it out of the scientific notation. If it's a positive number, it's going to be a big number, so we're going to move the decimal in that direction when we take it out of scientific notation. Okay, and then here's some good examples.